Hi guys, so welcome back to our mathematics tutorial. So this is a continuation of our previous lesson. So this is question number 11. We're asked to differentiate cos of x raised to the power y equals to cos of y raised to the power x. So when we are done differentiating this, you can now use the same method to be able to try these problems because these are all similar to this. So we have cos of x raised to the power y equals cos of y raised to the power x. Now, like we did for power rule, wherein y equals to x raised to the power n, and then we said to find its derivative, we have y prime equals to n x raised to the power n minus 1. Now, this n represents real numbers, but for this case, n is not a real number any longer. So if this was a real number like 2, 3, 4, negatives, whatever the case might be, we would have just dropped this power, subtract 1 from it, and differentiate inside. But that's not the case. So what we need to do, our focus is to ensure that this y comes down and this x comes down. So we know what can bring those expressions down is this rule from the logarithmic properties. Ln of a raised to the power r is equals to r ln of a. So if we apply this, if we apply the ln on both sides, take the ln of cos of x raised to the power y, and we take the ln of cos of y raised to the power x, we know that this is a raised to the power r, so this r can just drop, which is now y now, so y drops, we have ln of cos of x. So this x also comes behind. We have x ln of cos of y. So now we can differentiate using the product rule because we have an algebraic expression and a logarithmic expression. So we have the factors of two different expressions, so we must use the product rule. So we hold one of the expression y and differentiate ln of cos of x. So this gives us 1 over sine of x, and then times the derivative of this cos of x, which is now minus sine of x. Sorry, this is 1 over cos of x, because you're just rewriting this, and then you differentiate inside now. That's when we got the minus cos of x. Then plus, so since we held this one first, we held this y and differentiated ln of cos of x, we must now hold ln of cos of x and differentiate y. So the derivative of y, since y is the name of the function, is just y prime. Y prime times the ln of cos of x. So we're done with the left side. Let's go to the right hand side. In a similar manner, we can hold this x and differentiate ln of cos of y. It gives us 1 over cos of y times the derivative of cos of y, which is now negative sine of y, times the derivative of the angle. Now, the reasons why we did not bother ourselves to differentiate the angle here, because the derivative of x is just 1. But for this case now, the derivative of y is 1. But since y is the name of the function, we must be able to attach y prime. So we're done with this. Say plus, we hold on to this ln of cos of y now and differentiate x, which will just be 1. So it's just the ln of cos of y. So now we can simplify. Remember, all of the terms with y prime, we must group them one side of the equation so that we'll be able to solve for y prime. So to simplify in this, the first area, we have minus y sine of x all over cos of x, and then plus y prime ln of cos of x, all equals minus x y prime, and then this is sine of y all over cos of x, cos of y, and then this is plus ln of cos of y. So remember, our target is to ensure that all of those terms with y prime be grouped on one side of the equation. So we know that sine of x all over cos of x is just equal to tangent of x. So let's group them. Let's group the terms with y prime on one side of the equation, so that we'll be able to solve for y prime. So we now have this and this. So this gives us y prime ln of cos of x. And then if this comes across, it will be positive x y prime. Now, sine over cos is just tangent of y, all equals. So on that side, we have ln of cos of y. So if we send this term across, it will be positive. But sine over cos is now tangent. So it's positive y tangent of x. So we have y prime and also y prime. We can factor out y prime. So if y prime comes outside, we're left with ln of cos of x. And then this side now is, this is now plus x tangent of y, all equals to ln of cos of y plus y tangent of x. So we divide both sides by this expression. On both sides, we will have y prime to be equal to ln of cos of y plus y tangent of x, all over ln of cos of x plus x tangent of y. So this is exactly what we're going to get for this problem. So thanks all so much for watching. You can practice using these problems. Please practice. Take the ln on both sides and apply the same method. Take the ln on both sides and apply the same method. So you see that, yeah, it's cos of x, cos of x. So I just changed it to cos of x, and if I just change the power now to x, and then this is y. Initially this was y, and this is x. So the x was paired with y and the y was paired with x. But in this case now I pair x and x, y and y. So just practice using the same method and you're going to get your answers correctly. So thanks all so much for watching, and see you in our next lesson.